Good morning, everyone. Thank you for joining us today. In our last deep dive, we got a really close look at cobots and how they're transforming the factory floor, working right beside us. While today, we're zooming out. We're going to follow that same automation technology as it breaks out of the factory walls, as it gets, well, unleashed into the wild, complex, and unpredictable world all around us.
You know, for decades, if you said the word robot, the image that came to mind was probably a giant, powerful arm, maybe stuck in a cage on an assembly line, doing the same exact thing a million times. It was powerful, for sure, but only in that perfectly predictable, structured environment. Well, that story's changing, and it's changing fast. The core technologies that made those factory robots possible, things like advanced sensors, incredibly sophisticated AI, and fine-tuned control systems, they've matured. They've become so robust that they're now ready to step out into the messy reality of our wider economy. So let's see what that actually looks like.
All right, so here's our roadmap for today. First up, we're heading to the farm to explore the digital harvest. Then we're scrubbing in and entering the high-stakes world of the operating room with the Precision Partner. From there, we'll dive into the massive global supply chain with the Engine of Commerce. And we'll wrap things up by looking at some of the most dangerous and extreme jobs on and off the planet in the new frontier. It's going to be quite a journey. Let's get into it.
So, our first stop is agriculture, and the challenge here is just immense. We have to figure out how to feed a global population that's heading towards 10 billion people by 2050, and we have to do it sustainably, using less water, less fertilizer, and less land. The only way we can possibly square that circle is by making farming radically smarter. We need a fundamental shift away from the old way of doing things, farming by averages, and into a whole new era of farming with absolute precision. So that brings up the big question. What exactly is precision agriculture? Well, at its core, it's about a total change in philosophy. It's about no longer treating a 100-acre field as one single, uniform entity. Instead, you treat it like a complex mosaic, a community of thousands of individual zones, or even individual plants, each with its own unique needs. And the key piece of hardware that's unlocking this future, well, it's the humble tractor, which is getting a truly game-changing autonomous upgrade. And this table really lays out the massive technological leap we're talking about. You see, an autonomous tractor isn't just a tractor that drives itself. It's a mobile data collection and execution platform. It's equipped with something called RTK GPS, which stands for real-time kinematic. Now, the GPS in your phone might get you within a few feet of your destination. RTK gets this tractor down to centimeter-level accuracy. That means it can plant a seed, spray a nutrient, or till the soil in perfectly straight lines year after year without overlapping or running over existing crops. Then you have the 360-degree stereo cameras. These aren't just regular cameras, they create a constant real-time 3D map of the environment, giving the onboard deep learning AI the depth perception it needs to identify and navigate around any obstacle, whether it's a rock, a tree, or an animal. A farmer can literally just draw a path on a tablet, hit go, and the machine works tirelessly 24/7, day or night. This completely changes the farmer's job from being a machine operator to being a farm data analyst, making high-level strategic decisions instead of just driving in circles.
Okay, so the autonomous tractor is a revolution on the ground, but to be truly precise, you need to see the big picture. You need a view from above, because before you can act with precision, you first have to see with precision, and this is where agricultural drones are completely rewriting the rules of crop monitoring. And this is just incredible. Drones equipped with multispectral cameras can see parts of the light spectrum that are totally invisible to us. You see, healthy plants are packed with chlorophyll, which is fantastic at reflecting near-infrared light, or NIR. But when a plant gets stressed, maybe from a lack of water, a nutrient deficiency, or a disease, the chlorophyll content drops, and it starts reflecting that NIR light differently. An AI platform can analyze these subtle changes across an entire field and generate these amazingly detailed vegetation health maps. It's like giving the farmer X-ray vision. They can spot a problem brewing in a specific 5-foot patch of the field weeks before that patch would ever look sick to the naked eye. This allows for that surgical intervention we were talking about, treating just that one little spot instead of wastefully spraying the entire field just in case. It saves a fortune, and it's a huge win for the environment.
Now, this idea of surgical intervention brings us to one of the most difficult, labor-intensive, and chemically dependent jobs in all of farming: weeding. For centuries, you had two options. You could pull weeds by hand, which is brutally slow and expensive, or you could blanket spray the whole field with herbicide, which is wasteful and has serious environmental consequences. But what if a machine could have the same discerning eye as a human, but at a massive scale?
And here is the jaw-dropping result. This is not an incremental improvement.
We're talking about a revolutionary leap. These see and spray systems are mounted on a boom, and as they move across the field, high-speed cameras are constantly scanning the ground. An onboard AI, a computer vision model trained on millions of images, can identify, in milliseconds, the difference between a stalk of corn and a weed. The instant it identifies a weed, it triggers a single specific nozzle right above it, which delivers a tiny microdose of herbicide, zap. Just the weed. The result is a reduction in herbicide use of more than 90%. That is just a staggering improvement in both economic efficiency and environmental sustainability. It's a total game changer.
Okay, so from the wide-open fields, we're now moving into the sterile, high-stakes environment of the operating room. And the whole philosophy of automation here is fundamentally different. In healthcare, it's not about replacing the incredible skill of a surgeon. It's about augmenting that skill. It's about giving them tools that allow them to achieve a level of precision and control that is literally superhuman.
And the absolute classic example of this is the Vinci surgical system. Now, it's been around for a while, but it's really worth breaking down from a technical standpoint how it functions as a direct extension of the surgeon's hands and eyes. It is a true force multiplier for human expertise. This is really where the magic happens. So the surgeon isn't standing over the patient. They're sitting comfortably at a console, looking into a viewer that gives them a magnified, high-definition 3D image from inside the patient's body. Their hand movements control the robotic arms, but the system's software adds some incredible enhancements. First, there's tremor filtering. Every single human hand has a natural microscopic tremor. The Da Vinci's algorithms completely filter that out, making the robot's movements perfectly steady. Second, it uses motion scaling. The surgeon can move their hand a full inch, and the system can translate that into a perfectly controlled 1 millimeter movement of the instrument tip. And finally, and this is crucial, the tiny instruments on the end of the robot's arms are wristed. They can bend and rotate 360 degrees, far beyond what a human wrist is capable of, which allows for incredible dexterity in very tight confined spaces inside the body.
Okay, so all of that tech is absolutely fascinating from an engineering perspective. But what does it actually mean for the person on the table? What's the so what for the patient? Well, the impact has created nothing short of a paradigm shift in what's possible in surgery. And this slide just illustrates the difference so clearly. Think about traditional open surgery. It often requires a very large incision, cutting through layers of skin and muscle to get to the organ. That means significant pain after the operation, a much higher risk of infection, and a recovery that can take weeks or even months. Now, compare that to robotic surgery. It's what we call minimally invasive. The instruments are inserted through a few tiny incisions, sometimes no bigger than a keyhole. For the patient, this translates to a world of difference. Drastically less pain, a much lower risk of infection, minimal scarring, and most importantly, a dramatically faster recovery and return to normal life. The technology doesn't just make the surgeon more precise, it fundamentally transforms the entire experience and outcome for the patient. All right, from the sterile world of the OR, we're now shifting gears to our third section, the massive global engine of commerce. Think about it. The explosion of e-commerce has completely changed our expectations. We now want everything delivered tomorrow or even today. That has put an almost unimaginable strain on the entire supply chain. And frankly, automation is the only technology capable of meeting that kind of demand at scale. To really get your head around the modern fulfillment center, you have to go back to a company called Kiva Systems, which Amazon cleverly acquired back in 2012. They didn't just try to make the old warehouse model faster. They fundamentally reimagined the entire logic of how a warehouse should operate.
And this is the absolute genius of it. For 100 years, the warehouse model was person to goods. A worker would get an order and then walk, literally for miles and miles every single shift, up and down aisles to find the items on static shelves. It was incredibly inefficient. Kiva flipped that model completely on its head. They created a goods-to-person system. Now, a massive fleet of small, autonomous robots slides under a mobile shelving unit, a pod, lifts it up, and brings the entire pod directly to a stationary worker at a picking station. The worker takes the item they need, and the robot takes the pod back. This simple idea eliminates almost all of the unproductive travel time, making the picking process at least 3 times more efficient. It's a total paradigm shift in logistics.
So while robots like Kiva's have transformed the inside of the warehouse, another form of automation is tackling the infamous last mile problem, that final and most complicated and expensive leg of the delivery journey. And interestingly, the most successful and impactful drone delivery operation in the world today isn't in a major American city. It's saving lives in rural Africa. The Zipline system it's breathtakingly effective. Imagine a health worker in a remote village clinic. They need a rare blood type for an emergency transfusion. They send a simple text message. At a central distribution hub, that order is packed into a small box and loaded into a fixed-wing drone. The drone is launched into the air with an electric catapult and flies autonomously at over 100 kilometers an hour directly to the clinic's GPS coordinates. As it passes overhead, it drops the package, which floats down on a small parachute. The drone doesn't even land. It just turns around and flies straight back to the hub for its next mission. This system turns a journey that could take 4 or 5 hours over dangerous, washed-out roads into a delivery that takes maybe 15 minutes. This is a case where automation is literally the difference between life and death.
Now, for our final section, we are heading to the truly new frontier, environments that are, by their very nature, chaotic, unstructured, dangerous, and unpredictable. We're talking about places like active construction sites, disaster zones, or even other planets. In these places, robotics isn't just about being more efficient. It's about doing things that are either physically impossible or unacceptably risky for a human being to even attempt.
This question really gets to the heart of one of the original dreams of robotics, right? To build machines that can act as our proxies, as our stand-ins. We can send them into environments where humans simply cannot or should not ever go, whether that's thousands of feet under the sea, into the heart of a nuclear meltdown, or across the surface of Mars.
And this slide gives you just a taste of these incredible applications. On a constantly changing construction site, you have amazing machines like the Hadrian X, a truck-mounted robot that uses laser guidance to lay bricks with superhuman speed and precision. In space, you have the famous Canadarm2 on the space station, and of course, rovers like Perseverance, which are essentially our robotic field geologists on another planet, acting as our remote hands and eyes. In the aftermath of an earthquake, agile four-legged robots like Spot can carefully navigate the treacherous rubble inside a collapsed building to search for survivors without risking the lives of human first responders. And deep underwater or inside nuclear power plants, specialized submersibles and crawling bots perform critical inspections in environments that would be instantly lethal to any person. In every case, they are our proxies, extending our senses and our reach into the unreachable.
Phew, okay, we have covered a lot of ground. We've gone from the farm to the operating room, from the logistics hub to the surface of Mars. So after seeing all these incredibly diverse applications, what's the thread that ties it all together? What is the one big, unifying theme you should really take away from all of this?
So here it is, the grand unifying theme. The robot has well and truly left the factory. That core technological loop of sensing the world, using AI to think about it, and then taking precise physical action, that loop is now being applied everywhere. Across all these different sectors, we've seen how automation is a tool that augments human capability. It makes us more effective, it keeps us safer, and it helps us tackle some of the most fundamental challenges we face, from sustainably feeding our population to delivering life-saving medicine and exploring new worlds. Automation is no longer a niche technology just for manufacturing, it has become a general-purpose tool for human progress. I really hope this tour has given you a clearer picture of not just what this technology is, but where it's all headed. Join us next time as we dig into the invisible architecture that powers all of this in an explainer we're calling the connected machine, IoT, cloud, and edge in automation. Thank you so much for watching. If you found this valuable, please be sure to subscribe to our channel, Tech, AI, and Beyond, for more deep dives into the technologies that are shaping our world.